The next set of identities that we're going to look at are the sum to product formulas. As the name implies, these are going to allow us to go from a sum of trigonometric functions to a product. We have sum to product formulas for the sine of alpha plus sine beta, for sine alpha minus sine beta, cosine alpha plus cosine beta, as well as for cosine alpha minus cosine beta. In example 8, we want to get some practice with these. We were asked to express each sum or difference as a product. The first one is the sine of 9x plus the sine of 5x. So we have the sum of two sines, which means we're going to want to use the very first one. According to our new sum to product formulas, this should be equal to twice the sine of essentially the average of the two angles. It's alpha plus beta divided by 2. That should be 9x plus 5x divided by 2 times the cosine of the difference of the two angles. That's alpha minus beta. That's going to be 9x minus 5x divided by 2. That's from our sum to product formulas. And now from here, the only thing we want to do is simplify the arguments. This is going to be twice the sine. 9x plus 5x would give us 14x, but then 14x divided by 2 would be 7x, times the cosine of 9x minus 5x is 4x, and then 4x divided by 2 would be 2x. We have successfully taken the sum of two sine functions and written it as a product. Let's take a look at the next part. In part B, we're asked to write the cosine of 4x minus the cosine of 3x as a product. For this particular one, we're going to be using this formula here. It's the cosine of alpha minus cosine beta. This is going to be equal to negative 2 times the sine of the first angle plus the second angle divided by 2 times the sine of the first angle minus the second angle divided by 2. And then again, the last step is just to simplify the arguments. This would be 2 times the sine of, it's going to be 7x divided by 2 times the sine of x divided by 2. And that's taken us from a difference to a product. We have one more problem in this section where we're asked to verify the following identity. We want to show that the cosine of 3x minus 5x divided by the sine of 3x plus the sine of 5x is equal to the tangent of x. Let's go ahead and do this. So the first thing we would notice, if we look at the cosine of 3x minus the cosine of 5x, that looks like the difference between two cosines, which we could write as a product. And in the denominator, we have the sine of 3x plus the sine of 5x, which again we can write as a product. So let's use our brand new formulas for this. In the numerator, the cosine of 3x minus the cosine of 5x, that should be equal to the following. That's going to be negative 2 times the sine of 3x plus 5x divided by 2 times the sine of 3x minus 5x divided by 2. In the denominator, for the sine of 3x plus the sine of 5x, we can write that as 2 times the sine of 3x plus 5x divided by 2 times the cosine of 3x minus 5x divided by 2. From here, a few things we can do. We can cancel the common factors of 2 in both top and bottom. So we're going to have a negative. Let's simplify the arguments. This is going to be the sine of 3x plus 5x is 8x, and 8x divided by 2 will give us 4x. We now have the sine of 3x minus 5x is negative 2x, divided by 2 will be negative x. In the denominator, we're going to have the sine of 3x plus 5x is 8x, divided by 2 is going to be 4x. And then we have the cosine of 3x minus 5x is negative 2x, divided by 2 is going to be negative x. From here, one of the things that we notice is we have a common factor in both numerator and denominator. The sine of 4x's cancel, leaving us with the negative of the sine of negative x divided by the cosine of negative x. And now we're almost done. We can use the even and odd identities that would say that the sine of negative x is the negative sine of x, and the cosine of negative x is simply going to be the cosine of x. The negative of sine of x is just negative sine x over cosine of x. And then from the quotient identity, that's simply going to be equal to the tangent of x, which is what we were trying to show. So we have now verified that identity.